Hi Coach, this is video number 8 using a photoresistor, modified. And this is the layout of the board. We have 3 LEDs, light emitting diodes, and we also have an RGB LED, and we have 6 100 ohm resistors, as well as a 10,000 ohm resistor, which connects to the photoresistor. And so we have 10 through 5 input-output holes set for the LEDs, and then we have the 3.5 cable powering this section of the board, which powers the photoresistor, as well as we have the ground, which brings it back to ground over here. And here's the photoresistor. There's a red power cable right here that goes through it, and then it goes to the 10,000 ohm resistor, load resistor, which resists the currency, the flow of voltage in the circuit, so we don't blow out all of our LEDs and our resistor. And it goes back to ground through the green cable. As well, the LEDs, they go through the jumper power, and then they go through the ground on this side, all of them, and then they go to the ground over here. Here is the code portion. First, we start by setting the LED pins as well as the sensor pin to 0, and we set its light cal and light val so we can use them later in the code. So we set the BLE peripheral so we can use Bluetooth, and then this is the setup loop right here. So we start by setting the outputs using the array we made up here for the LEDs. We just set the outputs in a for loop, so it's just less coding. It's a lot easier, less redundancy. Then we set the peripheral, so we set my name of my board here, and then the rest set the value to 0, and then we begin with this statement. Start the void loop by just reading what the light value is, which is the sensor, the photoresistor. Then down here, if any characteristic written other than 0 on the Bluetooth app, any value input other than 0, the photo LED loop method will turn on. And down here we just set, this is the photo LED loop, which is our loop to make the LEDs flash. And so we just set tool 1 so we can prime this while loop so it runs forever. In the while loop we have the light value, and it's just a variable called light val, and it's going to read the sensor pin. And if that value is less than the light cal, which is the original value we set for light cal, which is before even being any light or any darkness is upon it, just sets the original value. So then it will know if there's any change in light. So if it's dark, then it will enter this if statement right here. Then sensor pin 0, we read the sensor value, then we print it out in the serial monitor. We have our 2 indexes, which we use for random numbers. So we'll pick a random LED and flash it. It'll just pick 2 random LEDs, because we'll put those both on high, and then we'll delay it, and then it goes on low, which means they turn off. And then if it's not dark, or if there's not any shade on it or anything, it'll just keep everything on low. So here's this me powering the board with the Bluetooth. So we'll start.
Imagine if you could walk around.
Switch to unit 8 so we can input a number 1, and now our board should be on. So how this works is, if there's any darkness presented upon the photoresistor, then it'll just start going. The LEDs will start flashing. And so if there is more darkness, or if the light value is a lot less than it was before, then it will go faster. And then if it's just a little, go a lot slower. Here is the serial monitor, and if we put our finger over the photoresistor, we get different amounts, get different sensor values.
You doing it? Yes. Wait, how do you get 1, 2, and 2?
And thanks for watching.